Hey class, Mr. Moyuddin here with a video example here of how to use the limit definition of derivative, sort of the long way, the classical way, without using rules and shortcuts. So just a quick review, this is the limit definition of derivative right here. I've given these other notations here just to emphasize that they're all the same thing. So it's the difference quotient, which is this item here, the slope formula, as the gap between the 2 points shrinks, approaches 0. So let's dive in. Find f prime of x. F of x is equal to 3x squared minus x minus 2. I didn't have room here, but the instructions would say, just like it does on your handout, that use the limit definition of derivative to find f prime. So when you see limit definition, that means do it the long way. Now, it's good to check, now that we've recognized and discovered the power rule, that the answer should be, so in our cloud bubble here, or meatball of thought, we know the answer is going to be 6x minus 1, just using the power rule. So the question is, how do we get there? The long way, by from scratch, essentially. So, whoops, wrong tool. The definition of derivative means f prime of x is equal to the limit as delta x approaches 0 of exactly what was on the previous slide. Only monochromatic here. Whoops. Okay, so now all it is just a matter of plugging it in. Now I'm going to try to fit this all in one slide, but if need be I'll move to multiple slides to keep it legible. So f of, big old huge fraction bar, f of x plus delta x. So everywhere I see an x, I'm going to replace it with x plus delta x. So very patiently here, 3x plus delta x squared minus x plus delta x minus 2. My fraction bar was insufficiently long. So that's the first part of the difference quotient there, minus the original function, f of x, so that's just minus, I'm going to put this in brackets here, 3x squared minus x minus 2, all over, whoops, apologies for the tech difficulties, all over delta x. So quite a monstrosity there. So the limit continuing as delta x approaches 0. Let's go ahead and expand the numerator here. So using the fact that this is a binomial squared, this would be 3x squared plus 2x delta x plus delta x quantity squared minus, going to go ahead and distribute x minus delta x minus 2, and this fraction bar will be quite unwieldy. And go ahead and distribute the other negative there, minus 3x squared plus x plus 2. Whew. All over delta x. Yikes. Hope you're enjoying these morning zoo crew style sound effects. Limit as delta x approaches 0 of, go ahead and distribute the 3x squared plus 6x delta x plus 3 delta x squared minus x minus delta x minus 2 minus 3x squared minus x, plus x plus 2. So that is quite a beast. So now we can do some cancellations now that all our parentheses are evaporated. 3x squared minus 3x squared. Don't see any of those, don't see any of those. Minus x plus x minus 2 plus 2. So lost quite a bit of troops there. So let's go ahead and see if we can simplify this. Alright, here it is on the next slide. Somehow changed color. So this is what we had after cancellation. And what you should notice, and this should be the case whenever you're doing problems like these, delta x appears in all three, so I can factor it out. But notice that I can't completely remove it from the problem, but that's okay. So delta x on the bottom, so factoring it out leaves me with, in the first term, just 6x plus 3. Well, I have 2 delta x squared, so I can only take one of them out, so 3 delta x remains minus 1. If you're ever not sure, simply redistribute and you should have what you started with, and you'll see that you do. So here's the key insight. You can't divide by 0, So 0 on the bottom here is no good, but as soon as you see this, boom, you see that 0 is actually removed. So the limit as delta x approaches 0 of no longer a fraction, 6x plus 3 delta x minus 1. We can now plug 0 in for delta x, leaving us with 6x, 3 times 0 is 0, goodbye, minus 1, and as promised, there's the answer, goodbye.